Good morning, lovely 13s. Right, buddies, as you can see, I'm not with you today. Unfortunately, I have been track and traced on the NHS COVID app, and so it seems as though I need to self-isolate. It looks as though I was near to somebody who's got COVID-19 based on the app there. So unfortunately, I won't be able to be with you until next Friday. So I'm out for a little while, buddies. But that's alright though. We can still do our amazing lessons, but in an online format. So just so you guys know, we've done this already before because I was also in quarantine when I first came back to England. So yeah, you're familiar with it anyway. I'm not going to set you any homework, so homework is now stopped. Your new work that you're going to be doing is following along with these videos, trying to keep up with them, and then just completing the classwork, taking a picture of that, and uploading it onto Show My Homework. So that's what we're going to do for the next, I think it's only just 2 lessons for you guys for the next 2 lessons till I get to see you again. Not this Friday, but next Friday. So sorry about that, buddies, but I guess, yeah, if you're flagged up by the app, you've got to isolate because that is for, yeah, to keep everybody safe. So yeah, that's where we're at. So here we go, buddies. Title for today is Addition Formula, or the Addition Formulae. Now, essentially, buddies, this is just more trig. So we're on the next unit of trig now, and it's just a little bit different trig. So the formulas are kind of complicated. So what you should do is you should jot them down in your book somewhere where you're going to be able to see them, to have them handy, because they're kind of a pain to memorize, as you can now see. And here they are. Here's the first couple. So essentially, these addition formulae are for when you have 2 angles added together. So for instance, or well, not for instance, it says sine of A plus B. So you could do this for, say, sine of 15 plus 30, and you'd be able to use this formula to work out things about a sine of 45, like those special angles. More often than not, they're used kind of in identities, and they're especially used for integration, which you're going to see, not with me at all, I don't think, actually, but you'll see them definitely this year, and if you're in further maths, you're going to be like, oh, intimately acquainted with these formulas, so you're going to be, yeah, happy with that. So anyway, without further ado, here we go. If you have 2 angles added together, so it won't just be like sine of 45, it would be like sine of 15 plus sine of 30, for instance. It breaks down into this. It's sine of the first one times cos of the second one plus cos of the first one times sine of the second one. Looks like a pain. You can memorize them, though. The plus matches the plus, and it's sine, cos, and then cos, sine. But yeah, I'll tell you something cool about that in a sec. Similarly, it works for subtraction. Boom. So just jot that down. If you wanted to derive them, you can actually derive them geometrically. They're based on triangles and stuff. So yeah, they derive with that, but they're a fiddle to derive, so I'm not going to bother with it, I don't think. It's in your textbook, though, if you want to have a little look. Cool. Next one, cos for the addition formulae. Here's what you've got. It's cos of A plus B is this, so it goes cos, cos, take sine, sine. The sign in the middle, the plus becomes a minus. Similarly here, if it's cos of A, take B, it's cos A, cos B, plus sine A, sine B. So it's cos, cos, sine, sine again, but the minus becomes a plus. And finally, our monstrosity that you've always looked forward to, tan, of course, being the awkwardest of all of the trig ratios, awkwardest formulas too. So there they are, our lovely addition formulae, all 6 of them. So now you've got so many trig identities, my lovelies. I bet your head is spinning. So you'd be like, oh good, I get to memorize all of this stuff. So I know that sine squared plus cos squared is 1. I know that sine over cos is 10. I know what all those reciprocal trig ones are, and I know what the trig identities are that match with the reciprocal ones. And now I've got 6 more, you'll be thinking to yourself. That's fantastic. I have to memorize so much stupid formulas. Actually, you lucky ducks, they're in the formula book. So, woohoo, there you go. It's not as bad as you think. So this is it from, this is just cut and paste off your formula book. And just to make sure that you understand, can you see it says sine of A plus B, but you see it's a plus and a minus, right? And the plus is on the top. Well, all that means is the plus is with the plus here, okay? So the plus is on the top and the plus is on the top. That means the formula for sine of A plus B is sine of A cos B plus cos of A sine B, which matches up here. If you went to the minus one, though, sine of A minus B, it goes to the minus on the bottom. Whereas in the cos one, can you see that it's like plus minus, but this one's minus plus? That means when it's plus, it's minus, so the top matches with the top, and when it's minus, it's plus, so the bottom matches with the bottom. And that's how you read them in the formula book. So, hooray! That's all of your lovely addition formulas. Cool. So, here we go. Let's actually practice using a couple of them. This question is an absolute nightmare, but I found a couple like it, so we may as well have a go at it. I think it's good at practicing the formulas anyway, so yeah, let's do it. It says that given that sine of x, or 2 sine of x plus y is equal to 3 cos of x, take y, express tan of x in terms of tan of y. So, yeah, if you were entering a contest to make an outrageously difficult first question in a new unit, I think that this would definitely be like a gold medal question to look at. But let's have a go anyway. I think we'll crack it. It'll be amazing. Okay. Yeah, so we want to express tan x in terms of tan y. There's not any tans in it. What do you think we should do as our first question, buddies, or as our first step? Well, some of you, actually I think you'd be quite clever to think this as well. You might be like, let's divide both sides by the cos, because then sine over cos would be tan. But actually, you're a bit scuppered with that, because in this bracket here, it's x plus y, and this one's x take y, so we can't use the basic identities. The plus and the minus inside the bracket is breaking those things, so we have to use our new formulas. So here we go. Let's try to expand the first thing. So instead of instead of 2 sine x plus y, let's hit up the double angle form, or the, oh gosh, a spoiler on what we're doing next. Let's hit up the addition formulas on it, buddies. So sine of x plus y, what happens there? Well, x plus y would be sine x cos y plus cos x sine y from our formulas. Cool? Don't forget, formula book, so just pop them open beside you. You do not have to memorize these. Cool, let's try it. So here we go. It's going to be 2, and then I'm going to put it in a bracket to make sure it's really clear, and it's going to be sine x cos y. I remember the plus matches with the plus, and then this is going to be cos x sine y. You know, you kind of end up memorizing these anyway, buddies, even though it sounds like, well, even though you don't have to, maybe you'll end up memorizing them anyway. Okay, cool, and on this one here, 3, open bracket. Now, cos x take y, that's this majestic thing here. It goes cos cos plus sine sine, so the minus matches with the plus, cos cos sine sine. So here we go, buddies. Here we go. So it's going to be cos x, cos y. The sign changes for cos is plus, sine x, sine y. Cool beans. So we just turned what looks like an easy question into a nightmare question. Let's times out the brackets because we still have no idea how we're going to get tans yet. We do have sine x's and sine y's and cos x's and cos y's, so they're probably key to it, but we still don't know what we're doing yet. So here we go, times out the bracket. 2 sine x cos y plus 2 cos x sine y equals 3 cos x cos y plus 3 sine x sine y. Cool. Now, if you were me, what you'd do right now is you'd look for like terms. Is there any that have exactly the same like terms in it? Oh my god, there isn't. We're in a nightmare now, my lovelies. By golly, what are we gonna do? This is a really horrendous question. But I bet you can figure out something. I'm going to give you a hint. We want to express tan x in terms of tan y. So, in other words, we want this to be the subject. And here's your big hint. What could we divide? Is there anything, just look at this first term. Is there anything we could divide by in terms of x's and y's and sines and coses that would get me a tan x out of this first term, out of this 2 sine x cos y term? That's right, you could divide them, buddies. You could divide them by cos x. And that would get sine x over cos x, which would be tan x. Not only that, though, buddies, we want tan y's as well. So instead of just dividing by the one thing that we want, let's divide by both. Let's divide by cos x and cos y. Cool? Now, as you guys know, you can't just do that to one thing. We're going to do it to everything on here. Cos y. This is a nightmare question. I don't think cos x, cos y, and sorry, let's get this written down first. Cos x, cos y. I don't think that little flashes of genius like that are really as common, say, on your exam, but it is clever and it's useful for you to kind of think outside the box like that. The trick to knowing that we had to divide by those things again was just knowing that we're trying to get tan x's and we're trying to get tan y's, and so the only thing that you can really do is to divide by coses, because that cancels out the coses that are all hung about at the same time as turning sines into tans. So let's go and see what can we cancel. That's kill there, kill there. What else can we kill? Kill, 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 kill. And what do we got here? Oh, nothing. So it's not wonderful, but it's better. So here we go. Next step. 2 sine x over cos x is 2 tan x, which is good because we want that in our equation. Plus, we're going to get sine y over cos y, 2 tan y. This side we've got just a 3, which is a result. Sine x over cos x is tan x, so it's going to be 3 plus 3. Sine x over cos x is tan x, and sine y over cos y is tan y. So there we go, buddies. This looks a lot better now, because we've got our tan x's and our tan y's, but we want tan x to be the subject. That's the main thing to think about. So if I was you, I'd rearrange it so all the tan x's were on one side, and then I'd get it so that tan x was the subject. So now that we've done that really hard step, I think you should pause it and finish this. Pause. Go. Right, and you're back. So hopefully you got what I'm about to get. So 2 tan x, take away 3 tan x tan y. So all the x ones are on that side equals 3 minus 2 tan y. All the non-x ones are on that side. Tan x is common to the first two terms. Tan x, open bracket. 2 take tan y. This right-hand side doesn't have anything interesting, so 3 take 2 tan y. And then you've done it, my buddies. Look, tan x is equal to 3 take 2 tan y over 2 take tan y. Boom. Really hard. This question, I think, is just really made up for you in order to practice the formulas. So I think that that's kind of where you get questions like this from. I'm going to set you a couple so you can actually try using the formulas yourselves. But yeah, hopefully it's okay. It's just that first step was a nightmare, that's all. Cool. Should we try a funner one? Yeah, we should. Cool. I like these. I really like these. So here we go, buddies. I'm just going to do A, and then I'm going to leave B and C for you guys to do on your own. I'm not even going to take up B and C because I don't want this video to be like an hour long. So I won't even take up B and C, but you can see it's example 6, right? So if you want to, you can get these guys out of your textbook as well. Just check what the answer is from the textbook after you've had a go. I think at this stage it won't surprise you that I kind of do these things radically different to the way that the textbook does, because I swear my way is the easiest. I promise my way is the easiest. Hopefully you agree with me, but yeah, we're about to do it my way. So how exciting. Here we go. It says, given that sine of A is equal to minus 3/5 and A is between 180 degrees and 270 degrees, so A is a reflex angle in the third quadrant. It also tells us that cos of B is minus 12 over 13 and B is obtuse. Find the value of cos of A, take B. Right, buddies. I'm going to level with you straight away. Can you see that this is sine A right here? Instantly I can tell you right now, we're not going to be able to get, no, I'm not going to level with you straight away. Let's try to work it out. Let's just try it. Here we go. Okay, what are we going to do? If we're just doing A only, here we go. Is cos of A, take B. Now, that's absolutely useless to us, the way that it's written at the moment. And the reason for that is we only know about sine of A and we only know about cos of B. We don't know anything about those two angles added together, because don't forget these guys here, the minus 3/5 and the minus 12 out of 13, are not the angles themselves, but rather the trig ratio well, of opposite over hypotenuse that links to the angle A, and the trig ratio of adjacent over hypotenuse that links to the angle B. So it's right back to kind of the basics of what trig is. So, oh dear, we can't work with it as it is. So what are we going to do? That's right, buddies. What we're going to do is we are going to be using our sick new formulas, which we absolutely don't have memorized. I might have them memorized, but yeah. You go to your formula book and you're like, okay, which one's this one? This is the A take B one, which is this one. So it's cos A, cos B plus sine A, sine B. You'll use these so much you'll end up with them memorized, I imagine, though. But yeah, let's have a go. So my buddies, this straight away turns into this. It is going to be cos A, cos A, cos B. The sign changes on this one, so instead of minus, it's plus. And then it's going to be sine A, sine B. Cool. Right, now we're in a bit of bother because we know sine of A is minus 3/5, so that's good. In other words, this one here is fine, no problem. We know that cos B is minus 12 over 3, so there's our cos B, so that's fine too. But can you see that we have no idea what cos of A is? We have no idea what sine of B is. So we are stitched up here, unfortunately. So we're not ready to solve it because we don't know what cos A or sine B is. If only there was an amazing way to do it. If only you could cast your eyes over this question and figure out a really good way to do it. If only you could cast your line out for some amazing solutions. If only we could, if I could cast this into your brains right now, it would be amazing. Oh yeah, that's right, buddies. It is cast. Let's do this thing. Here we go. Okay, buddies. Now let's do it. We need to know what the other trig ratios are that link to sine of A. So here's what you're gonna do. We're gonna use some cast here. So here's for the sine of A one. Let's do it. Straight away, first thing to do is that we're gonna use cast sex and the city, or cast if you prefer cast. And here's what it says. It says that the sine of A is minus 3/5, and it also says it's between 180 and 270. So remember that's 0, 90, 180, 270, 360. So we live here in this quadrant. Cool. That's where that sine business comes in. That's where the sine of A malarkey comes from. Now, that means our angle A is actually this angle here. It's actually the longer one that goes all the way around to that, but you can think of it, so it should be this angle, but actually you can think of it as the acute angle that's in that quadrant instead, like we talked about in class. And so here we go. It says sine, as you guys know, is opposite over hypotenuse. So the opposite's a 3, and the hypotenuse is a 5. Now, always hypotenuse is positive, but you can see this 3 is below the axis. This is a minus 3. Cool? And that's where the minus 3/5 comes from. Now to get the other side, the final side, all you gotta do, buddies, is you can use Pythagoras Theorem on it. So to get this extra length, well actually it's a 3, 4, 5 triangle, so it's actually minus 4, that one. Minus, because it's left of the y-axis there. And it's Pythagoras' theorem, right? So it's 5 squared take 3 squared, so 25 take 9, which is 16, square rooted is 4, and that's where the minus 4 has come from. So there you go. There's one of our things. Well, now that you've got 3 sides of that triangle, now that everything is known of that triangle, you can tell me what cos of A or tan of A is. So we use sine of A to get the other two. Cool. We're going to do the same on cos B, though. So here we go. Cos B. Now, for the cos B one, we're going to Sex and the City this thing up again. Your textbook doesn't do it this way, but your textbook's silly. Sex and the City. What it tells us about this B one, it says that B is obtuse. Now, if B is obtuse but is, that means it's more than 90 but less than 180. So, which means this one here, the cos B lives in this section. So, B goes here, in that little corner there. The actual angle B is actually there to there, but again, like what we talked about, this inside, that whole big angle is actually the equivalent of this tiny acute angle that's in that quadrant. So that's how it works, buddies. So here we go. Cos is adjacent adjacent over hypotenuse. So hypotenuse is always positive 13, and adjacent is 12. Adjacent's on the bottom this time, minus 12 in this instance because it's left. Well, actually, buddies, this is another one of those special triangles. You get a nice whole number out here. You don't have to. You can get these things being surds as well. But yeah, we get another whole number here. 13 squared is 169. 12 squared is 144. 169 take 144 is 25. Square rooted for 5. So this is a 5. A positive 5 because it's upward. Cool beans? Sweet. Now, here we go. Using that, we can now solve this in one step. So let's rock on. Let's even celebrate by switching colors. Let's go to purple. Here we go. What's cos of A then? Well, if this one's A, cos of A, straight away off your picture, it's adjacent over hypotenuse, it's minus 4/5. Adjacent, hypotenuse, minus 4/5. So here's what, here's what we've got. Minus 4/5 off that. Cos of B then, that's this one here is the B one. Cos of B is going to be minus 12 out of 13. Beautiful. Happy days, eh? Oh, and actually, that's even given in the question. Plus then, sine of A is going to be minus 3/5 from the picture. Oh, and from the question. And sine of B, the one that wasn't from the question, that's this one on the right. This is the right one now. Sine of B is 5/13. So that's it, 5/13. Now all you're going to do, buddies, is bish bash bosh that into your calculator. Get what the answer is. Oh my god, when I'm doing it online, I actually have to type it myself. This is a nightmare. I'm used to you guys doing all the calculator work for me. 48 out of 65 minus 15 out of 65. Yeah, I think. And then 48 take 15. Oh, I should be able to do this. 43, 33. 33, I hope. You guys will tell me if I'm wrong, I bet, though. 33 out of 65. I think that's the answer. Cool, I didn't use a calculator. You should. But yeah, that's brilliant. When you try B and C on your own just now, what you should do is you should just, well, we've already done most of the work. We can use these same two pictures here, our cast pictures. We'll use those again, but you'll just use the different formula. You will use the tan double angle formula. In this cosec one, you'll switch cosec to 1 over sine first, then you'll just use the sine one. So yeah, happy days, no problem, eh? Cool. So here's what I'm going to say that you should do. I'm giving you like a lot of work, and we're actually going to do an extra topic today, but don't forget, I'm not giving you homework anymore. Here's what I'd say you should do right now for maybe another 20 minutes potentially. Can you please try question 8 and 9? Okay? 4 is a funny onion, but if you want to try 4, go for it. So 8 and 9, because they're kind of similar to what we just did now, and that's the context that I've seen them on your actual exams. Cool? So if you want to pause the video and have a quick go, that'd be a good idea. Just do question 8, and if you feel really confident, just do the one of them, because this kind of topic's going to get revisited in a sec anyway. Cool? Pause, go. Okay, so for our final topic today, I'm going to give you the most important kind of formulas that come out of these addition formulas. They're also called the compound angle formulas. I don't know why they're not called that in your textbook, but yeah, in my head, those were the compound angle formulas, the addition formulas, and now we're going to do the double angle formulas. Now, these are super awesome and super easy to derive. Are you ready? Double angle formulas. What they look like, and I'll do the easiest one with you to start with. They start like this. They start with sine of 2a. So if I was to give you a great big spoiler alert, right there, if I wanted to make sine of 2a, what does b equal to in this compound angle formula? What does b equal to if I was going to make sine of 2a? That's right, b would have to be a. If I want to make sine of 2a, then b is the same as a. If I set b equals a in this formula, well, then here's what I'm going to get. I'll get sine a cos a, sine a cos a, because the b's just got swapped for a's, plus cos a sine a. Which, by Jove, if you haven't spotted it, are exactly the same term twice. So it's 2 sine a cos a. Boosh! Your first double angle formula. These are critically important. I'll tell you about them really soon, I think. But yeah, these are critically important. First double angle formula. I'm going to let you in another secret as well. These are not in the formula book. But did you see how easy it was to derive? All I did was turn a B into an A, and that was it. Okay. Second one, my buddies. Second double angle formula is the cos one. What are we going to do to get the cos one? If you said exactly the same thing, you're exactly right. So you got to derive the cos one as well. So here you go. Cos of 2a. And that's just going to be cos a. Cos a. Take sine a. Now, if only there was a better way to write that. Oh, yeah, there is a better way to write that. Cos a is cos squared a. And sine a is sine squared a. Boom! Your second double angle formula, the one for cos. Now, this is going to seem weird. I bet you... Oh, what the heck? Let's just do the tan one as well. While we're at it, let's do the tan one. I'm going to put it to the right, though, and if you're writing along with me right now, which I hope you are, we'll do this one together as well, but we'll put it to the right because I want some space under the cos one, spoiler alert. So here we go. Let's quickly bodge out the tan one. Swap A for B, and here we go. Tan of 2a, it's going to be this. It's going to be tan a, tan plus tan a, over 1 take tan a, which you'll be correct to think simplifies to 2 tan of a, 2 tan a, over 1 take tan squared a. Boom. And there's your little trifecta of double angle formulas, but they get even better, okay? These three formulas are the basic ones. You'll use the sine one occasionally. You'll use this cos one, never. And you'll use this tan one, never, kind of as well. The reason that you never use the cos one, really, is because there's a way more useful variant of the cos one. Can you see that the cos 2a is cos squared a takes sine squared a? You guys also know the Pythagorean identity as well. You guys also know that sine squared a plus cos squared a equals 1 from this year and also from year 12. So you know those ones as well, right? So sine squared a plus cos squared a is 1. If you bodge, get rid of the cos squared and then also get rid of the sine squared, you get way better versions of this formula. So here we go. Let's do it. So cos 2a also could equal something else. If I get rid of this cos squared, I can swap that out for 1 take sine squared. Cool? Because of that Pythagorean identity I just did in purple up there. Take sine squared a. Cool. Which means cos of 2a is also equal to 1 take 2 sine squared a. Now that is used all the time. That and the one I'm about to do now are the two most important double angle formulas. This one's used all the time because it turns a squared into a not squared. So if ever you had to say a problem that, especially if you had to integrate, because you guys know all about chain rule and stuff now, you're quite good at chain rule and stuff. If you had to say integrate something, so you had to undo a chain rule when you integrate something, it's a real big pain in the backside to do, which you're going to learn soon. So if you could turn a squared into a not squared, that's a huge bonus, and that's why these formulas are good. You'll find out soon enough on your own, though. Same deal. Let's go from this formula again and get the final variant. Cos of 2a is equal to cos squared a, and this time let's swap the sine squared a out. So this will be 1 take cos squared a, and that means cos of 2a is equal to, minus and minus makes a plus, there's a plus cos squared a, so now there's 2 cos squared a's. Cos squared a, take 1. That's it. These two at the bottom are your superstars, though. Like these guys and these guys. Oh, you'll grow to love them. I love these. Your favorite formulas ever. By golly, they'll make you happy. So there you go. That's your two amazing ones. And here's all your other ones. Again, they're not in the formula book. But don't forget, the formula book looks like this. So you could absolutely derive these in under 30 seconds. In your exam, so it doesn't matter. You don't have to memorize them if you don't want to. If you're a memorizer, because you take if you take some memorized subjects and your brain works well that way, go ahead and memorize them, but if not, they're easy to derive. Cool, last question we're going to do together. Let's just do the sine 2a one, or sine 2x one. It works exactly the same as the previous question using the compound angle formulas. So here we go. It says sine of 2x, so let's do it. A, sine of 2x. Well, we are not given anything really of use here, because all we're given is that cos of x, which isn't even the angle that we're looking at, is 3/4, and it's between 180 and 360, so it's a big reflex angle. But all we've got is sine of 2x. If only sine of 2x would turn into something more useful. Oh yeah, it's 2 sine x cos x. How exciting! And look, we actually are already sorted on the one of these. We're already sorted on the cos of x. We know that's 3/4. The only thing that we don't know is sine of x. So if only there was a way to cast your mind on how to do that. Oh, my lovelies, it's cast. You've totally got sex and the city. You've totally got your head around it now, my buddies. Cool. Right, so here we go. It says it's between 180 and 360, which means it's in the bottom 2 quadrants. Oh, it's not leveled it down. Okay, cos is positive here and here, right? Cool, because it's positive 3/4. And it says it's in the bottom half, which means it's got to be in that one. So you can draw your sticks into there. Do you see how I did that? It's because it was positive, and this told me it was in the bottom. This told me it's positive, so it's got to be the C one. It's cos, which means our x is here. There's our little x. Cool. Now, the only extra thing we got to do as well, buddies, is let's get it labeled. Cos of x is adjacent, which is here 3 over hypotenuse, which is 4. It's a 3, 4, 5 triangle, so that's 5. What kind of 5 is it, though? That's right, it's a -5 because it's down, right? It's below the axes, so it's a -5. Well, that's it. You solved it, buddies. So much better than the way the book does it, I have to say. But yeah, that's perfect. 2, and sine of x now is just going to be -5/4. Cool? Because I read that off the picture. Cos of x is 3/4, because I read that off the picture, or I just nicked it from the question itself. Now, what we got to do is we got to use our calculators to times these out, or you can be lazy like me and not bother. 2, 1, and that means what we've got here is we're going to have a -15 on the top, and on the bottom we're going to have 8. It's -15/8. That's your final answer. If you want to do some practice, see if you can do B. It's just using the formula. We've already done the hard part. If you want to skip that, that's cool. And the last questions I'm going to get you to do are these. Page 176, 10, 13, 18. Okay? 9's a funny onion, but you're welcome to try it if you like. Cool. What do I want for your homework? How long has this video been? Oh my good heavens above, it's been 30 minutes. Can you just show me that you've done maybe 1 or 2 here? So maybe do question 10 only, or 10 and 13. And also in this one, can you do question 8 and 9? And that would be good. Just so you show me that you understood this and you had to go, because next lesson we'll be doing some practice. So that's it from me, buddies. Again, no more homework, so make sure that you're spend the rest of this period on it, and then also spend I don't know, an extra 20 minutes or half an hour outside of this period, and that's cool. Right, buddies, so good work. See you next time. Bye, lovelies!